So welcome to the Getting Started with Azure Infrastructure as a Service session. My name is Michael Washam. I am an Azure MVP and the CEO of Opsagility. We are a training company that focuses on cloud-first enterprise training. You can follow us on Twitter or through our website. So Microsoft Azure is built on 24 regions worldwide that you can deploy workloads into. 19 of these are currently online, but on top of these data centers, where you can actually deploy workloads, is a service called Infrastructure Services. This consists of virtual machines, storage, virtual networks, load balancers, and so on. That is going to be the primary focus of this session. On top of IaaS sits a whole series of services that you can build net new applications on. These consist of Azure Web Apps, cloud services, databases as a service, all kinds of tooling and components that you can literally put together to build new applications and workloads. So as I mentioned, this session is mostly focused on IaaS, and inside of IaaS, there's even a lot of services as well. So we're really going to narrow it down and focus on 3 key services for a Getting Started session. These are virtual machines, virtual networks, and Azure storage. So the first thing I want to answer is why infrastructure as a service. One of the key things you should understand is you can deploy virtual machines and other workloads such as storage and networking anywhere there's an Azure region met. This means you can deploy to any of the 19 regions and deploy your workloads without you having a physical presence there. You can run virtually any Windows or Linux-based workload. It's very flexible. And Azure provides built-in services for monitoring, scale, and automation that you don't really have to do a whole lot to take advantage of. And in addition to this, Azure provides flexible hybrid connectivity options to connect your data center to the cloud or to connect cloud to cloud in different regions. So let's kind of walk through and compare a traditional deployment on physical hardware versus a deployment in Azure. So deploying it traditionally into your infrastructure. In most organizations, if you're doing a net new deployment with physical hardware, the very first thing you need to do is order it. And depending on your agility with procurement, this could take anywhere from a couple of days to several months. The next thing you're going to need to do is deploy the networking infrastructure. This is the routers, the switches, the cables, the physical or software-based load balancers, basically all the low-level networking infrastructure needed for the deployment. From there, you're going to deploy the server infrastructure itself, setting up the blades, updating firmware, things like that. And of course, once you have the blades and the servers installed and configured, you have to install and of course patch the operating system. After that, you have to install and configure the actual application workload. And finally, if you have multiple environments, dev, test, staging, or whatever, you're going to have to repeat many of these same steps to have multiple environments. Now, if we're going to compare directly with Azure, and in this case, we're actually just going to compare without automation, which is one of the key components of cloud computing, but just to kind of compare apples to apples. The first thing you're going to need to do in Azure is to deploy the virtual network. This is a completely software-based solution, so you're not deploying physical hardware unless you're doing some kind of hybrid connectivity. But for the most part, it's all going to be through your browser. After that, you will deploy the virtual machines and, of course, configure the load balancer. Again, these are all software-based components, so it could be just directly through your browser. And this is still infrastructure as a service. You still have full control over the virtual machines that you're running, which also means that you're responsible for patching the operating system. And after that, of course, you're installing and configuring the applications. And if you do have multiple environments, you're still going to repeat a lot of these same steps. Now, the benefit here is even though this doesn't have automation, there's still some significant advantage and agility gained by deploying directly in the cloud because you're no longer managing the underlying physical infrastructure. Now, let's compare one of the key advantages here with Azure or the cloud in general is you can automate and programmatically create and manage resources. So with automation, very first thing you're going to need to do is get your developer team and your IT teams together to identify processes and systems that are repeatable or that are very sensitive to configuration management. Once you've identified those, you're going to build automation assets. These are things like scripts, templates, things like that can basically build or configure your environment. After you build the automation, it's literally just a matter of actually executing it. These could be scripts or templates, but the goal is they should be idempotent, which means they can run over and over again to produce identical environments, or if they're updated, to actually change the existing environment. And if you have multiple environments, you can simply change a parameter on your automation script, re-execute it, and generate an identical new environment. So this is very simple for developing new dev, test, or staging environments. So now let's talk about some of the key capabilities and features of IaaS, namely virtual machines and virtual networks. So virtual networks are essentially the ability to create a private network in the cloud. It supports hybrid connectivity to on-premises or to other Azure regions. And of course, you can also control network traffic segmentation and virtual appliance support with features such as network security groups and user-defined routes. With virtual networks, you can deploy most compute, such as virtual machines, Azure Cloud Services, or even Azure App Services. So let's walk through a real quick demo on how to deploy a virtual network. So I'm going to switch over to the Azure Management Portal. And the first thing we're going to do is go to New. Once we're in New, we can go to the different resource types that we can create. In our case, we're actually going to create a virtual network, so that's going to be under the networking group. So I'm going to select virtual network, and there's two different deployment models, Classic or Resource Manager. Resource Manager is the newest model that you can create resources in. So I'm going to choose it. And here is where we can actually name our virtual network. So I'm going to call this AzureCon VNet. And you can see that we can define our address space here. The address space is the available IP addresses that are usable within your virtual network. You can change this to a smaller subnet or a smaller address space, or you can also add additional address spaces after the virtual network is created. Each virtual network has a default subnet when you create it, and we can change the name of this. And after it's created, we can go back and add additional subnets if we want to. And finally, I'm going to configure the resource group. Now, the resource group is a container that you deploy resources such as VMs and virtual networks, etc. And the resource group should group resources based on the life cycle of the application. In this case, a virtual network is going to be a shared resource, so I probably don't want to deploy applications directly in this resource group because it's kind of a resource group onto its own self. So I'm going to call this AzureCon VNet Shared RG, just as a naming convention so I know that it's shared amongst multiple other applications. And the last step is the region that I want to deploy the virtual network into. And in this case, it's going to be West US. So I'll go ahead and click Create. And now Azure is actually creating and deploying the virtual network. Now that the virtual network is created, all we need to do to add additional address spaces or subnets is click the Settings button. And you can see that we can go ahead and add additional address spaces, add additional subnets, and we can even add DNS servers. And what a DNS server does with a VNet is whenever a resource like a virtual machine is deployed to a virtual network and a DNS server is defined, it will automatically be assigned to that resource whenever the virtual machine boots up. And we can also define who can manage this virtual network using role-based access control. And we can also tag this resource so we can let other users in Azure know whether this is part of a dev test environment or whether it's tied to a specific cost center. The next feature I want to talk about is Azure Storage. Azure Storage is a multi-tenant and highly scalable storage system that's used by most services in Azure. Specifically with virtual machines, it's used as a disk subsystem for each one of your virtual machines. Some of the key benefits of Azure Storage is it provides you automatic local redundancy. So every disk that you deploy in Azure Storage is automatically replicated 3 times locally. So you basically have a 3-copy mirror of every disk in Azure. You can really simply change a storage count property to make it geo-redundant as well. And what this means is your 3 copies that are replicated locally will also be replicated to a remote region. So Azure Storage comes in 2 service tiers, Standard Storage and Premium. And Premium actually supports up to 5,000 IOPS per disk because it's based on high throughput, low latency SSD storage. Azure Virtual Machines, of course, are the compute option we're talking about today. And it's really the most flexible compute option you can deploy in Azure. It supports deploying any workload on Windows or Linux. And you can create virtual machines that range anywhere from a single CPU with 768 megs of memory all the way up to the largest virtual machine you can deploy in the cloud with 32 procs and 448 gigs of RAM. Virtual machines can be deployed on standard or SSD-based storage, and with the largest instance sizes, you can deploy up to 64 terabytes of storage per virtual machine. So let's talk about some of the built-in capabilities that Azure provides that makes it much easier to configure availability and scale. So deploying virtual machines into a feature called an availability set provides you automatic physical redundancy. Basically, it tells Azure to deploy multiple virtual machines that deploy the same workload onto multiple racks in the Azure data center. This gives you automatic physical redundancy at the network, power, and cabling level. And it's very simple to configure, as we'll see in the demo coming up. Another capability that you should know about for availability and, of course, scale is the Azure Load Balancer. The Azure Load Balancer allows you to load balance traffic that comes from the public internet, or if you're deploying an intranet-based workload or a middle tier, you can have it load balance a private IP address off of your virtual network. This is known as internal load balancing. The Azure Load Balancer supports TCP or UDP-based protocols, has a configurable idle timeout, and you can configure TCP or HTTP-based health probes, and it also supports flexible affinity options such as 5-tuple, 2-tuple, or 3-tuple, and these options give you different options for distributing network traffic across your virtual machines. So another feature that helps dramatically with scale and also cost and agility is the auto-scale feature. The auto-scale feature basically solves the problem of under or over provisioning workloads. So what it essentially does is it stops virtual machines or starts virtual machines based on a metric. This could be a performance metric such as CPU. It could be the number of messages in a queue, and it could also be just based on a schedule. And it's relatively simple to configure, and just kind of to walk through how it works. As new load is added to the service, your virtual machines will automatically be started to accommodate that increased load. As load is taken away, the virtual machines are stopped. And the benefit here is whenever a virtual machine is stopped by autoscale, you're no longer charged for that compute time, just the underlying storage. So over time, this can save a dramatic amount of money based on the size of your service. So let's walk through and show how to actually create a virtual machine in the Azure Management Portal. So I'm going to flip over to the Azure Preview Portal, and I'm going to go to New again. And this time, instead of going to Networking, I'm going to go to Compute. And under Compute, you can see all the different virtual machine images we have, ranging anywhere from Server 2012. We also have Windows Server Container Preview. So if you do want to try out bleeding edge images, are available right there. And of course, Linux and different deployments such as SQL and SharePoint. If you go into the Azure Marketplace, you can also see third-party Azure certified solutions, such as firewalls and gateways and all kinds of other interesting solutions. So for this example, we're just going to create a Windows Server machine. And I'm going to, again, pick Resource Manager. And what I'm going to do here is configure some of the basic properties of the VM, such as a VM name. So I'll call this AzureCon VM Demo. And next, I'm going to set the local username and password on the VM. And I'm going to go ahead and create a new resource group. And again, I'm going to go ahead and keep the region to be West US, just like the virtual network. Next thing I want to do is actually configure the instance size. So you can see that right off the bat, Azure is recommending a couple of instance sizes. But if I click the View All link, you can see a much wider selection. And these are the much larger or even sometimes smaller instance sizes. So I'm going to go ahead and choose the DS2 standard. And the reason I want to choose the DS2 instance size is because it provides support for premium disk support, which is SSD-backed storage. From there, I can go in and I configure a storage count. And this is what's needed to actually configure Azure Storage. And you notice by default, we have premium enabled since we selected a DS instance size. Next thing I want to do is actually deploy this virtual machine to the virtual network that we created earlier, the AzureCon VNet. And a couple other things we can change. We can select a subnet. If we added additional subnets to the virtual network, that would be listed here. We can also use a public IP address if we want to. And if we want to configure network rules with a network security group, which can control inbound or outbound traffic, we can control those right here. So at this point, the last thing I want to set is an availability set, just to show you how easy it is to configure it, where we can have multiple physical redundancy. Of course, to truly take advantage of an availability set, we would need to create a second virtual machine for the workload, but just to kind of show you what's involved here. It's literally just naming the availability set, picking a little configuration, which we're not going to go into in this session, and clicking OK. And at this point, we just have to click OK one more time, and our virtual machine will be created in the virtual network that we provisioned earlier. Now, while that's provisioning, I want to show one more thing. I have another virtual machine that's already provisioned. I really just want to show you how simple it is to add additional storage capacity to an existing virtual machine. So this virtual machine has been pre-created, and all I have to do to add additional storage to it is go under All Settings and Disks, and there's a button on the toolbar called Attach New. And here's where I can pick the disk size. For standard storage, you can specify any size that you want up to 1 terabyte. With premium storage, you pick 128, 512, or a terabyte. So depending on the size of disk you want. So in this case, I'm going to go ahead and attach a 1 terabyte SSD disk to the server. And that's literally all it takes to attach additional storage to a virtual machine. Now, the next capability I want to discuss is hybrid connectivity. Hybrid connectivity is essentially the ability to connect your data center to the cloud or a data center in the cloud to other parts of a cloud. Azure provides 3 separate options: point-to-site, site-to-site, and express route. Point-to-site, just at a high level, allows you to connect an individual computer, such as a laptop or a file server or whatever, directly to a virtual network using SSTP, so traditional VPN software. It's really good for remote development and test, remote admin, or simple proof of concept efforts. Site-to-site connectivity allows you to use secure IPsec VPN to connect one or more networks from on-premises directly to Azure or from Azure to Azure, whatever you want to do. The use cases here are really just hybrid connectivity directly to your virtual machines or Azure Cloud Services. And the final option is Azure Express Route. Azure Express Route is private, dedicated connectivity between your data center and Azure, but it also involves using a third-party Express Route partner. So just to kind of walk through a real quick diagram of how site-to-site and point-to-site could be deployed. In this example, we have 2 virtual networks, one deployed in West US, and the other is deployed in East US. The 2 virtual networks are connected to an on-prem data center called the corporate network here, using secure access with site-to-site. There's also 2 additional computers connected to the virtual networks, the secure admin and secure dev and test. And these are, in this example, literally individual laptops that are connected using point-to-site. And the benefit of point-to-site is it's much more secure to connect using secure VPN than connecting to virtual machines in a virtual network using a public IP address. Azure Express Route is a much more scalable solution for hybrid connectivity. It comes in 2 flavors. The exchange provider flavor, and this is really where you will partner with a colocation provider or an internet exchange provider like Equinix or Level 3, companies like that. And essentially, you're going to run a direct connection from your cage in the colo center directly to Azure. The bandwidth here ranges anywhere from 200 megabits per second all the way up to 10 gigabits per second per circuit. And the beauty is you can actually have multiple circuits for availability and increased performance. The network service provider model performs a very similar function, except it's really designed for companies that already have existing wide area networks or establishing wide area networks. Essentially, when you deploy ExpressRoute with the network service provider model, you're extending the wide area network with Azure, is what it comes down to. The bandwidth in this model ranges from 10 megabits per second all the way up to 1 gigabit per second per circuit. So let's walk through a real quick demo of an existing hybrid connectivity solution deployed. So back in the Azure Management Portal, I'm going to go to Browse All, and this is essentially the same diagram that we just saw in the slides. If I go down to Virtual Networks, you can see that I have 2 virtual networks that are already created, one in Ops East VNet, which is in the East US region, and Ops West VNet, which is in the West US region. If I open up each of these, you can see that the address space for East is 10.2.0.0, and the address space for West is 10.1.0.0. And we're referencing out DNS server 172.16.0.2. This DNS server is actually in the on-prem data center, so it's not part of either Azure address space. One thing that's really handy for virtual network management and other resources in Azure is the Azure Preview Portal allows you to take these tiles, like the current status of our VPN connections, and literally pin them to the start board. So I can pin Ops West VNet, and I can also go pin Ops East VNet to the start board, and then I can basically make a real simple dashboard that shows the current state of my network connectivity. So you can see that East is connected to West, and also West is connected to on-prem, and vice versa. East is connected to West here and back to on-prem. One other thing I'll note is it's showing the connectivity between a client and point-to-site. Now, if I look, this is actually my laptop. I'm connected to Ops West VNet via point-to-site connectivity. So I have direct connectivity between my machine and a virtual network in Azure, which means I can connect to those virtual machines using an internal IP address, not just a public IP address. Now, let me validate that connectivity is actually working. I have a virtual machine already deployed in these virtual networks called Cloud Shop Web. So I'm going to go ahead and connect Cloud Shop Web directly over RDP. And you notice this is actually connecting to the public IP address. And the reason is because I have not removed the public endpoint. But the benefit of using point-to-site is instead of doing the public IP address, I can also use the internal IP address. So if I go to IP addresses, you can see that this machine is assigned the internal IP 10.1.0.4. And I can launch client here and connect directly to this machine using the internal IP address, which I could actually close off from public access. And now I have secure connectivity to this VM. Now, one other thing I want to demonstrate is from within this virtual machine, I can reach out to my on-prem network. So I can ping 172.16.0.2, which is an Active Directory domain controller connected via site-to-site VPN. And just to validate that I have name resolution, I can go and ping contoso.com, which is the name of the domain that I'm deploying to. So one benefit, real quick benefit, there's several others, of course, for hybrid connectivity in a Windows environment, is Azure provides the ability to automatically join a virtual machine to an Active Directory domain at provision time. And of course, you can do this through the portal, or you can do it through an automated deployment. So if I wanted to deploy a Windows server and have it automatically part of the domain whenever it boots up, it's relatively simple for me to do that. So I'm going to go ahead and name this VM AD joined VM, specify the local username and password, and I'm going to deploy this virtual machine to the same network that my Active Directory is configured on. That way I can reach the domain controller. And that would work with either Ops West VNet or Ops East, either one, because they're both connected back to the on-prem network. And to configure domain join, it's under the OS settings section. And I can go under domain join, specify the domain to join, which is contoso.com, and specify the credentials that have access to join a computer to the domain. And like I mentioned, you can do this as part of an automated deployment too. Now, literally, when this virtual machine is provisioned, it will be part of the Active Directory domain. Now, the last topic I want to mention is automation and agility. So the cloud has significant advantages over deploying this in your own environment because automation is built throughout the platform. And one of the capabilities is virtual machine extensions. Virtual machine extensions are essentially extensibility endpoints that you can call during deployment or after a virtual machine is deployed. You can call it as part of an orchestrated automation, or you can just do it during the portal, which I'm going to show you here in just a minute. But what the extensions do is they give you the ability to deploy things like anti-malware, just reset the local password. You can configure things like Docker or Azure Backup, or deploy antivirus, or all the way just to executing PowerShell scripts or configuring Chef and Puppet. Very extensible in what you can do with the virtual machine extension. Another automation asset that you should be aware of is Azure Resource Manager resource templates. The benefit to deploying a template is it's not only just about the inside of a virtual machine, but you can actually model the entire infrastructure of your deployment. And it's not just for deployment either. You can use it to update an existing deployment. Now, what that really means is that you can version control your entire infrastructure. You can model a deployment for a SharePoint farm, an IaaS web farm, an Apache deployment, MySQL, it doesn't really matter. And one of the other key benefits here is it's not just for IaaS. You can model a template that has IaaS components and platform as a service components like web apps and SQL database. And of course, let's not forget the command line tools. Microsoft Azure provides a rich set of PowerShell commandlets for Windows PowerShell users. And also, if you're not a PowerShell user, but maybe you run on a Mac or on Linux, there is a set of command line tools that are cross-platform that run on Windows, Mac, or Linux. Both sets of tools allow you to create and manage resources in Azure, and of course, actually execute managed templates as well. So let's walk through a really quick demo about automating virtual machines. So one of the first things I want to show is an extension. So what I'm pulling up here and what I'm showing on the screen is PowerShell DSC, or PowerShell Desired State Configuration. What this script does is if I run this on a machine, it will ensure that the IaaS Windows feature is installed. It will ensure that ASP.NET 4.5 is installed, and it will ensure that the source or the content in the node.sourcePath variable is copied to inetpub wwroot. So now the question is, what is node.sourcePath? If I look, I have a separate file here that's specific for parameters, and node.sourcePath is defined as a file share. And on this file share, I happen to have an ASP.NET application that's copied there in the build share, ready to deploy. So essentially what happens is when this script is going to run, it's going to automatically install a web server and deploy a web application. Now how we can do this through Azure is a couple ways. Using the management portal, I could also use PowerShell or the cross-platform command line tools, or I could use an ARM template. In this case, I'm going to keep it relatively simple and just show how we could apply this extension on an existing virtual machine using the portal. So I'm going to go to Browse All, and I have a virtual machine here called CloudShop Web that is ready to be installed with a web server and an application, but does not have one just yet. So to install this extension, I go under All Settings, Extensions, and I click Add. And here's a list of all the extensions you can deploy directly from the portal. The one we're interested in is the PowerShell Desired State Configuration extension. And this is what allows me to execute that script directly on the virtual machine, completely remote, without actually ever logging into it. So I'm going to go ahead and browse to the script file that I just showed you. I already have it packaged up in a zip file. And browse to the parameters file that tells which file share to pull the application from. And the last thing I need to do is specify the name of the module within the script to execute. And that is cloudshop-dsc.ps1/cloudshop. And once I press OK, that script will automatically be uploaded to Azure, deployed to the virtual machine, and executed on. So in about 10 minutes, we'll have a working web server. So that's one key aspect of automation that we should see. Now, that is actually just customizing the inside of an operating system that's already deployed. Now, how would we actually deploy full-blown infrastructure and the operating system, end-to-end automation? And we can do that using an Azure Resource Manager template. Now, what I'm showing here is a repository on GitHub. So if you go to github.com/Azure, Azure is the organization account for the Microsoft Azure team. It's where they open source most of their projects and their tools. And under the organization, there's a repository called Azure Quick Start Templates. Each one of these items here is an ARM template that does a different thing, whether it's creating internal load balancers or availability sets or key vaults. They're basically a set of samples that you can use, customize for your own environment. Now, what I'm going to walk through is show how to deploy a SharePoint farm with just a few clicks. So there's two templates in here we can use for SharePoint. One of them is the SharePoint Server Farm-HA. This is a fully highly available SharePoint farm. So it's going to deploy anywhere from, I don't know the exact number of cores, but probably right around 30 cores just for this deployment. And the second model is a non-HA. So it's just basically a 3 farm or a 3 VM template. So this one is probably better getting started example. Now, if you look inside of here, there's a lot of different files. The first 3 zip files are pretty much exactly what I just did before. They're a set of PowerShell scripts that configure SharePoint, SQL, or an Active Directory domain controller. There's a bunch of other files here for creating storage accounts, configuring public IPs, and so on. Now, we're not going to go into the minutia of template building today, but I will show you how you can actually just try this out on your own. The GitHub repository has a nice little extension built called Deploy to Azure. So I can click this button, and it's going to do a deep link directly to my Azure subscription in the Azure Management Portal. And when it loads, the template and all the necessary parameters will be defined inside the portal for me already. So if I click on Edit Template, you'll see all the JSON that was in that repository already embedded in the deployment script. So now if I go to parameters, you can see that it parsed all the parameters out of that JSON file, and it's really just looking for input on all the different values it needs to deploy. So what it's looking for here is the name of a storage account, and a storage account name does have to be unique. So we do need to put a couple of unique values in here to make sure it's not in use already. it's going to also want to know the region to deploy it to. So this template only has West, East, and West Europe, and East Asia, Southeast Asia defined, but these values can be whatever is acceptable for whatever the template should be. And there's a lot of default values in here that we can go ahead and accept. And then the rest of them, for the most part, there's a couple at the end that are not, but the rest of these are going to be the password for the various service accounts get created for your SharePoint farm. So I'll go ahead and fill in a few of these. And at the very end, it's looking for DNS names. And basically, each tier is going to have its own public DNS name. And we need to go ahead and create these. We'll go ahead and call this one AzureCon AD service. And of course, this one does need to be unique too. And we'll make one for SQL as well. And of course, SharePoint. Now, the last step we need to do is accept the legal terms. Oh, one more step I'm missing is the name of the resource group. So we're going to go ahead and create one more resource group for this. And that way, all of these resources will be created in one group. And the beauty here is whenever we're done using this SharePoint farm, we go delete the resource group, and it takes care of deleting all of the resources within it. So it makes cleanup much easier. Now, this template will actually take at least an hour or two, maybe, to deploy all the way, because it's doing a lot of orchestration. So I've already have an existing SharePoint farm that I've deployed. And just to kind of give you an idea of all the resources that template creates, this is literally everything that same template creates. You're having different availability sets for each tier. You're having different VMs, load balancers, network interface cards, public IPs, the virtual network, and of course the storage count. So you can kind of get a feel for the capabilities of what an Azure Resource Management template can do. As you can see, there's a lot more to learn on Azure Infrastructure as a Service. So I've compiled a list of getting started resources here, documentation for virtual machines, networks, ExpressRoute, so on, and also a link to documentation for the Quick Start templates. So thank you very much for watching the session. I hope you enjoyed it.